Hello everyone, how are you? I hope you are all doing well. In this video, we are going to solve numericals based on the topic like force, which is related to the magnetic force in moving charges and magnetism. Okay, so there is one question given. What is the magnitude of magnetic force per unit length on a wire carrying a current 8 ampere and making an angle of 30 degree with the direction of a uniform magnetic field of 0.15 Tesla? So what is given in the question? Let me write. They have given, first of all, the current in the wire, that is I equals to 8 ampere. And then the magnetic field is given as B equals to 0.15 Tesla. And the angle between the, we can say, the wire and the direction of the magnetic field is theta equals to 30 degree. Now we have to find out the magnetic field, magnetic force per unit length. So as we know that the magnetic force on a current carrying conductor in a uniform magnetic field is given by the magnitude, actually I'm writing F equals to ILB sine theta. So this is the magnitude of the magnetic force which will be acting on that wire. And here in this question, they are asking us to find out the magnitude of magnetic force per unit length. So we have to take the force per unit length. So it will be F upon L. So the equation will become as IB sine theta. Now let's place the values. So it will be F upon L equals to the value of I is 8 and the value of B is 0.15 into sine 30 degree. Now, as we know that the value of sine 30 degree is half, so it will be 1 by 2. Now, let's solve the equation. And as per the equation, the unit of force per unit length is Newton per meter. So F upon L will be 8 will be divided by 2, so we will get 4 into 0.15 Newton meter inverse. And then finally, the force per unit length will be 0.15 into 4 is 0.60 Newton meter inverse. So this will be the force per unit length acting on the that current carrying wire. One second. Okay, so this will be the force per unit length acting on the that current carrying wire. Now let's solve the another question. And in this question, they have not given the direction of the current, so we cannot find out the direction of magnetic force also. But if they have given us, we would have find out. Question number two. Question number two is, let me write. Question number two is a 3.0 centimeter wire 3.0 3.0 centimeter wire carrying a current of 10 ampere carrying a current of 10 ampere is placed inside a solenoid is placed inside a solenoid inside a solenoid perpendicular to its axis perpendicular to its axis. Okay. And the magnetic field inside the solenoid is the magnetic field, the magnetic field inside the solenoid is given to be 0.27 Tesla, is given to be 0.27 Tesla. What is the magnetic force on the wire? And the question is, what is the magnetic force on the wire? Okay. So it is the similar question. In this one, they have given us the length of the wire also. In the previous one, they have not given us the length of the wire. So the solution will be, length of the wire is L equals to 3.0 centimeter. So basically we can write 3.0 into, wait, 3.0 into 10 to the power minus 2 meter. And the current in the wire is I equals to 10 ampere. And its axis is like the wire is perpendicular to the axis of solenoid. That means the angle between the length of the conductor and the axis of the solenoid is 90 degree. And the magnetic field inside the solenoid is given as B equals to 0.27 Tesla. Now we have to find out the magnetic force on the wire. So first of all, the angle between the, we can say the direction of current or the length is 90 degree. So the magnitude of the force will become as ILB sine 90 degree, or let me write the magnitude of the magnetic force is F equals to ILB sine theta. And here the theta is 90 degrees. So the equation will become as F equals to, the value of I is 10 and the value of length is 3.0 into 10 to the power minus 2 into the magnetic field is 0.27 Tesla into sine 90 degree. And the unit will be Newton. Now the value of this final calculation, we can find out it is F equals to, basically it is 10 times 3.0 into 10 power minus 2 and 0.27 into 10 to the power into sine 90 degrees. So let's solve it again. So 10 into 3.0 into 10 to the power minus 2. And this can also be written as 2.7 into 10 to the power minus 1. And the value of sine 90 degrees is 1. And the unit is Newton. So the force will be 3 times 2.7. So it will be 8.1. 8.1 into 10 to the power. Here there is 10 multiplied by 10 to the power minus 1. So it will be 10 to the power 0 only. So it will be 1. So final, the 10 raised to the power minus 2, 10 raised to the power minus 2 Newton. So this will be the total force acting on the that wire. Okay. Now let's solve another question. Question number 3. In this question, they have given two long and parallel straight wires A and B. Two long two long and parallel straight wires. Parallel straight wires. Straight wires A and B. A and B carrying current so carrying current so carrying currents of 8.0 ampere, 5.0 ampere in the same direction are separated by in the same direction are separated by separated by uh, a distance of 4.0 centimeter by a distance of 4.0 centimeter. Estimate the force on a 10 centimeter section of a wire A. Estimate the force on a estimate the force on a 10 centimeter section of wire A. Okay, so in this question, it is different from the previous two questions that we have solved. In this question, they have given us the two parallel wires. Okay, and the current into them is IA is 8.0 ampere and current in wire B is 5.0 ampere. And they are separated by a distance of 4.0 centimeter. So D equals to 4.0 centimeter, and it can be written as 4.0 into 10 to the power minus 2 meter. And we have to estimate the force on a 10 centimeter section of wire, 10 centimeter section of a wire A. So here the length of that wire is, the section of that wire is 10 centimeter, or it can be written as 10 into 10 to the power minus 2 meter, like this. Okay, as we know that the force, they are asking us to estimate the force on a 10 centimeter section of wire A. Okay, so that force will be due to the wire B. So that can be written as FBA. Like the force due to wire B on wire A is mu naught IA IB times L upon 2 pi D. Now let's put the values. So we will get FBA equals to the value of mu naught is 4 pi into 10 to the power minus 7 into the value of IA, that means the current in wire A is 8.0 ampere and current in wire B is 5.0 ampere, and the length is 4.0 into 10 to the power minus 2, and it is divided by 2 pi into the length, the separation between the wire is 4.0 into 10 to the power minus 2. Sorry, we have put the wrong value of L. Okay, the length of the wire, length of the section of the wire. So let me write it again. So it will be 10 into 10 to the power minus 2 Newton. Now let's solve the question. So finally we will get FBA equals to here 4 pi, this 2 pi will cancel 4 pi by 2. Okay, so here the equation will become, and this 8 will be cancelled by 4, and we will get here 2 and minus 2 and 10 raised to the power minus 2 and 10 raised to the power minus 2 will be cancelled out, and finally we will get 2 into 10 raised to the power minus 7 into 2 into 5 into 10. This will be the equation, and finally we will get the force as 2 into 2 4 and 4 5s are 20, right? So it will be 200 times 10 raised to the power minus 7 Newton. Now later on, to get the it will be 2.0 into 10 raised to the power minus 5 Newton only. This will be the force acting on the wire A due to wire B. And since they have given us the direction of the current, they are parallel to each other. So we know that in case of parallel currents, they attract each other. Okay. So the nature of the force will be attractive force